Hello friends, very good morning to all of you. My name is Shikhar Verma and today we are going to discuss a Linux booting procedure, and I hope you will find this video very useful in understanding the booting process of Linux. So let's start. So how Linux boots? The very first thing is power up reset button. Once we click on power button or reset button, it starts booting your system. Once it starts booting, the CPU jumps to the address of BIOS. So we can say the very first thing comes into the picture once the power on, that is your BIOS. BIOS is nothing, it is the interface between your hardware level or software level on a very basic level. The few things happen at the BIOS level, that is your post is your power on self test, whatever the hardware we have on your server, on your system, so it checks all the CPUs, memories, whatever connected at the very basic level. This is what we call post. After post, BIOS always keeps the hardware information of your bootable device. It retrieves that information from your CMOS. CMOS is your complementary metal oxide semiconductor. It's a battery operated memory chip on your motherboard that stores your hardware information of your bootable drive, your time, data, and some critical information also it keeps. So here we have two things for a BIOS, that is a post, and it keeps the information of your bootable drives. Now BIOS, it always reads the first sector of your bootable drive. After that, BIOS functionality is completed. Okay, so what we have at the first sector of your bootable drive, that we will discuss in detail. Okay, so BIOS, it reads and execute the first physical sector of your chosen boot media. This is usually in the first sector, and it is 512 bytes of the hard drive. BIOS execute a short program that is stored in the MBR of the physical drive. Okay, so what is that? What is your 512 bytes? This is what we call MBR. MBR is your master boot record. MBR is always in the first sector of your bootable drive, and it contains the primary bootloader. Okay, here we have two types of bootloader, two stage of bootloader, that is a stage 1 bootloader and stage 2 bootloader. Okay, so what is stage 1 bootloader? What all the information we have in the MBR? Okay, let me open one picture that will give you a clear idea about your MBR. Oh, where's that picture on? Okay, see this picture. I am talking here, the MBR is in 512 bytes. So what the information we have in 512 bytes? First 446 byte is your bootloader. This is your first stage bootloader. It keeps the sector information of your secondary bootloader. Okay, and next is 64 bytes. It is your partition table. Whatever the partitions we have at your bootable disk, so this keeps the information of partition table. And the next is your magic number. This is your 2 bytes. Magic number, it maintains the integrity of your master boot recorder. Whatever the information we have in the master boot recorder, so it keeps the integrity. Like if something goes happen on your MBR, so magic number will let you know like there is some issue. If you boot your system, if your MBR got corrupted, so you will start getting errors that is related with your magic number, something number. So we will come to know like this is the problem, there is some problem with your MBR. Okay, now we have discussed first sector of your bootable drive, that is your MBR. We have segregated the MBR in 3 sections. First, your first bootloader. First bootloader is your 446 bytes. This doesn't contains the actual bootloader, it contains the sector information of your secondary bootloader. Okay, secondary bootloader that resides in your /boot partition, /boot grub, /boot/grub. So it will tell you like where is your main bootloader, and then bootloader boots the kernel into the memory. This is the functionality of bootloader. Everybody knows that what is the functionality of bootloader. Bootloader is basically loads the kernel into the memory. So MBR we have discussed. MBR is always in the first sector of the bootable drive, and it contains the primary bootloader. MBR is of 512 byte sectors located in the first sector of the disk. Okay, and normally written in assembly language. The MBR that is written in assembly language. Okay, first bootloader, it keeps the sector information of your secondary bootloader that is stored in /boot/grub directory. Okay, and partition table and then magic number. If you want to see, let me show you in the let me show where is your first stage bootloader that we are discussing. 446 bytes. See this, I have logged into one system and I have come to this directory /boot/grub. If I am doing LSF and LTR, see this stage 1, this file, it is showing your first stage bootloader. If I am doing file stage 1, it will show you that stage x86 boot sectors. Okay, or we can also read this what we have in the MBR. So how we will read this? First of all, we should know what is your bootable drive name. This is your /dev/sda. Okay, we will use dd command. Let me do one thing. Font size, appearance. Change the okay, now we are going to show. I am saying stage 1 is your primary bootloader, and what we have in the stage 1 bootloader, I am saying it keeps the sector information of your secondary bootloader. So I am going to show you how it is like that. So I am going to read the MBR. So the command is dd, and if /dev/sda, this is your input file, and I am redirecting the output of that file in anywhere. I can put it in /temp mbr.bin. okay, that would be the output file of your my. Okay, and block size I am keeping here 512 bytes, and I am giving the count is 1, so it will read block size 512 bytes and of your bootable drive, that is your /boot SDA, and redirect the output in this /temp mbr.bin, and it will do for one time because I have given count is 1. Okay, it's done. To read this hexadecimal file, we have a command od-xa. I am not going in detail what is od and what is x. I am just showing you. See, this is I am telling two types of bootloader, stage 1 and stage 2. Stage 1, it keeps the sector information of a secondary bootloader. So if I am doing this command, you can see a lot of sector information is showing. Okay, don't try to understand what this sector information is saying, but just to understand, like, this keeps the sector information of your secondary bootloader. It tells where is your secondary bootloader, I hope that would be more understandable to you. Okay, now come to the stage 2 bootloader. What is stage 2 bootloader? Okay, if I am going ll command, it is showing a stage 2 bootloader. Okay, this is your main bootloader. Okay, So bootloader, what is bootloader? Our default bootloader is grub, Grant Unified Bootloader, and this is your default bootloader, and it is independent to the OS. Okay, it's a separate, you can say, interface from where you can do a lot of troubleshooting as well. I will let you know how to do this. Okay, so let's see some basic idea about grub. Grub is your Grant Unified Bootloader functionality. It's to load the kernel into the memory. Okay, and flexible command line interface, we can say. And stage 2 bootloader, it is in /boot/grub directory. Okay, and stage 2 bootloader presents a boot menu to the user based on /boot grub, and grub.conf is a file for that. And bootloader is basically loads the kernel into the memory. Okay, let's see what other bootloaders we have. If you have HP servers, our bootloader is EFI, Extensible Firmware Interface. Alpha platforms, we have Milo. DOS based servers, we have Loadlin, and so on. We have lots of bootloader, but here we will discuss about more about your grub bootloader. Okay guys, let me come to the next topic of the boot stage. Okay, we have come to the grub. Okay, okay, give me 2 minutes guys. Okay, now after this what happens? Now secondary bootloader we have, where secondary bootloader is your grub, and it will try to load the kernel into the memory. Okay, load the kernel into memory, what does it mean? It means mounting the root file system, then only mounting the root file system into the memory. This is what the kernel is doing, bootloader is doing. Okay, but here the question is that the Linux kernel needs to mount the root file system, and to do so the kernel typically needs to load some modules. Okay, but this presents a quandary situation here, because where does the kernel gets the modules? Typically the kernel gets the modules from the /lib modules directory, but at the basic level the root file system is not mounted yet, and it cannot access the modules. Hence this presents a classic chicken egg situation. Kernel needs to mount the root file system, and to mount the root file systems we need some modules, and those modules are presented in /lib directory, that is a part of your root file systems. So this is a quandary situations, like we can say chicken egg problem. This chicken egg problem that we have already, if you will see your Red Hat book, it is clearly mentioned. So the grub loader and the kernel work together to provide a solution to this problem through the use of initial RAM disk, which is the part of your typically grub configuration for a Linux kernel. So what happened when the system, when we install the OS, at that time it creates a initial RAM file. This is called your init.rd RAM, or for Linux 5 we have init.rd. Let me show you the file name. This is your init.rd, and for version 6 we have ramfs file. Okay guys, so bootloader loads the kernel into memory. So bootloaders load the kernel into the memory, so it keeps those information from init.rd and mount the root file systems in read only mode at the initial level, and it loads the kernel into memory, and later on it mounted the root file systems in a read write mode. So what happened? The very first process, this is called sbin init. The process ID is 1. We say it's a mother of all process. So very first process, it starts init. Init reads its configuration from /etc/init tab, and to decide the run level. The run levels like as multi-user mode, full multi-user mode, graphical is your 5, 0 is your halt, and 6 your reboot. So let me open the file init tab. Okay, you can see this file. So this 3 is denoting your default run level. So once we reboot the system, it will come to the run level 3. If I am editing this file and putting 5 here, so it will boot your system into your 5 run level, that is your graphical. Okay, and see here what it is showing, all control del. It means if I am pressing all control del here, so it will restart your system. So always we hash this line, otherwise if somebody did it not intentionally but he fired this all control del, so it will start rebooting the system. And this is your all your run levels. Run level 1, run level 2, run level 1, it's denoting line, it's 2, it's 3, it's 4, and it's 5, and it's 6. Okay, respawn means if that particular terminal somebody tried to make it stop, so it will respawn, it will restart automatically. Okay, here in the last line you can see this is for run level 5. Okay, if somebody tried to stop this pre-FDM is basically the login screen that is started in run level 5. So if somebody tries to stop it, so it will respawn it will try to restart by automatically. Okay, okay, let me open the document. See, the first thing the kernel does it to execute the init program. The init is the root parent of all processes and executing on Linux. The first process, the init start, is a script that is called etc rc.d rc.sysinit. Based on the previewed run level, scripts are executed to start various processes to run the start and make it functionally. Okay, the init process is identified by process ID 1. Init is responsible for starting system process as defined in /etc init tab that we have already discussed. Init typically will start multiple instances like getty, which is waits for console logins, which spawns once user shell process. Okay, process ID, what we have, 0 is for scheduler, init process, and then okay, that we have, this is that we have already discussed. This is in a default run levels. Okay, this is one important thing here. What all are the run levels directories? Suppose we have chosen run level 5. So let me go to this etc rc.d. Okay, if I'm going to this directory /etc rc.d, if I am giving ls1ltr, I can see a lot of directories are there. One is init.d. If I am going to init.d and I am going ls1ltr, it will show you all the startup scripts. Okay, all the startup scripts are there. Okay, and I'm going one step back, and again I'm giving ls1ltr. It will show you the directory names, rc.6, rc1. Suppose I have selected run level 3. So whatever the scripts that is being decided is this directory rc3.d, it will start only those. It is symbolic link. If you will see, S is denotes for start IP tables, and it is symbolic link, that is a initd. Initd, init.d, init.d, we have all the scripts are there. So if you selected run level 3, so what all are the scripts that are being started having the symbolic link to that directory, and that will be started. Okay, if you will see, some is showing start S and some is starting with K. S denotes start, K denotes kill. Okay, suppose I am going from run level 5 to 3, so all the K will be selected. Okay, so these are the directories that will not be started at run level 3, and going from 3 to 5, it will be selected all the scripts that are showing S. But if we have selected 5, so we will have to go to for rc 5.d. Okay, so this is basically a simple boot process, and I hope this video gives you some little bit picture of your how this system boots. We have a lot of things to discuss here, but I hope that's enough for today's, and we will bind up and we will come with a more detail of booting process. Okay guys, thanks for listening my document. Feel